Hello everybody. So welcome back to Metric Hub. Thank you for tuning in. So guys, we are preparing for the upcoming trial exam. Okay. So we're going to do question papers together. Okay. So today I have a question paper here from Mpumalanga. Okay. Mpumalanga province. And so this paper was done in 2025. Okay. So this is a paper that was written in September 2025. Okay. So we're doing paper one. Um, so you can see, guys, it's a 3-hour paper and it's 150 marks. Okay. So we're gonna do this paper together. So this question paper consists of 10 pages, one formula sheet, and 22-page special answer book. Okay. And then, so we go to the instructions. Read the following instructions carefully before answering the questions. So they say answer all the questions. Clearly show all calculations. Okay. So I think the instruction that's important here is the rounding. Okay. Round off 2 decimal places. Okay. And say they say unless stated otherwise. So your answer should be 2 decimal places. Okay, what it should say is that a minimum of 2 decimal places. Okay. I think that's a more appropriate thing. So even if you do 3 decimal places, it's still okay. Because 3 decimal places is more accurate than 2 decimal places. Okay, so let's get into the questions. Okay, so question one. Okay, let's start with question one. 1.1, they say solve for x. We are required to solve for x here. Let us begin with 1.1.1. Okay. We have 6x squared minus 2x equals to 0. Okay. 1.1.1. Six x squared minus 2x equals to 0. Okay. So then what do we do here? Then we can take out the common factor. The common factor here and there. So what's going to be the common factor? It's going to be 2x. Can say therefore 2x, and then it's going to be into 3x minus 1 equals to 0. You take out the common factor. If you multiply 2x here, so that's the common factor. So then we have therefore 2x equals to 0, or 3x minus 1 equals to 0. So it means therefore x equals to 0 or x equals to 1 over 3. Okay. So this is 2 marks, guys, you see. There's 1 mark here and 1 mark there. So it's only 2 marks. And then the next 1.1.2, okay? 2x squared equals to 1 minus 4x, okay? 2x squared equals to 1 minus 4x. 1.1.2, 2x squared equals to 1 minus 4x. That means therefore, so we can rearrange this thing into a standard form. Okay, what is the standard form? Standard form is ax squared plus bx and then plus c. So we should rearrange this thing. So then we get 2x squared plus, so that the 4 becomes positive when it comes to the left, plus 4x and then minus 1 equals to 0. So it means therefore, okay, then we try to factorize here, okay? So we can't find factors here. If we can't find factors, we use the quadratic formula, okay? So then it's gonna be x equals to negative b plus or minus the square root of b squared minus 4ac, okay? And then divided by 2a, 2a. So then it's gonna be, so we look at the equation. This is b here, okay? This is b, the 4 here is b, 2 is a, and then negative 1 is c. So then we substitute, so minus b, so it's gonna be minus 4, and then plus or minus square root of 4 squared minus 4, and then multiply by 2, and then the c is negative 1. And then the a here is gonna be 2 multiplied by 2, okay? And then it's gonna be equals to negative 4 plus or minus square root of 24. So the 24 is what we get inside the brackets. Okay. So then it's going to be, so it means x is going to be plus or minus. So it means therefore x is going to be -4 plus square root 24 over 4 equals to, or x equals to -4 minus square root 24 all over 4 equals to. Okay, so you use a calculator at this point. You use a calculator to get the answers. So -4 plus square root 24 and then over 4. Okay, so it gives me, so in two decimal places it's going to give me 0.22. And then if we say minus at the top, we replace the positive with a negative. It gives me -2.22. Okay, yeah, that's it. So you see, these are decimal numbers. So it means we couldn't find the factors here. We couldn't find the factors that are whole numbers. The factors are not even rational. Okay, they are irrational numbers. So that's why we had to use the quadratic formula. Because there are no factors. The expression here on the left-hand side cannot be factorized. See, so we resort to the quadratic formula where we just use substitution of the values. So let's go to 1.1.3. Square root of x minus 2 plus 4 equals to x. And then so we can take 4 the other side. Then we have x minus 2 equals to x minus 4. And then we, in order to remove the square root here, what do? We introduce a square the other side. So if to remove the square root, we go the other side and we introduce a square. So it's going to be x minus 4 squared. Okay. So then x minus 4 squared will remove the square root on the left hand. Okay. And then so it's going to be, therefore, x minus 2 will then be equal to, when you expand this, because this is going to be expanded, and then it's going to be 2 brackets, x minus 4, and then x minus 4. So then it's going to be x minus 2 is going to be equal to x squared minus 8x so we can take the x, so the 2 will become plus 2 this side. So it becomes plus 2 when it comes to the right. And then the x becomes a minus. So it's going to be x squared. And then if we minus x here, it's going to be minus 9x. And then plus 18. The 18 came from where? It's 16. And then plus 2. We don't say minus because it changes, it becomes positive when it comes to side. Okay? So then we have to factorize. So we say 0 equals to, and then what are the factors here? It's x and x. And then it's going to be negative 6, negative 3. When you multiply 6 and 3, you get 18. So it means therefore, x equals to 6 or x equals to 3. So then we have to test these values. Are they applicable to the equation? Okay, don't forget, because this is where a lot of people make mistakes, because it doesn't end here, isn't it? The numbers have to be tested. If we put 6 here, if we say x is 6, it's going to be 6 minus 2, which is 4. Okay, so it's going to be square root of 4, which is 2. It's going to be 2 plus 4. Okay, so 2 plus 4 equals to 6. But then if we substitute 3 here, okay, if we substitute 3, it's going to be what? So watch this. If we say x equals to 3, it's going to be like this. It's going to be square root of 3 minus 2, and then plus 4 equals to 3. Okay, because wherever there's x, we have to substitute 3. So then this would mean that 1 plus 4 equals to 3. And 1 plus 4 is 5, you see. 5 is not equal to what? 5 is not equal to 3. So when we use 3 on the original equation, it doesn't give us a true statement because it says 5 equals to 3, and we know that 5 is not equal to 3. So it means that of the two solutions, x is not equal to 3. The solution of 3 is cancelled out, you see, so you must be careful here. Okay, x is equal to 6 or x is not equal to 3, because a lot of people leave it. At this point, they would say x equals to 3, and x is not equal to 3. It should be like this, okay? There should be a cross there, you see. So please be careful. You must always test your values. The value that you find, it must be tested, especially when there's a square root like this, because you may find that some of the values that you find are not real solutions of the of the problem, okay? So please be careful. Let's go to 1.1.4. So 1.1.4, let me try to do it here. (1.1.4), it says negative x squared minus x plus 12 is less than 0. So it means therefore, oh no, that's 1.1.5. Sorry. We're looking at number 4 now. So it's 3 to the exponent 4x, then minus 8, and then 3 to the exponent 2x equals to 0. So therefore, so now, okay, we want to reduce this thing too. So we can say 2x and then squared minus 8 and then 3 to the exponent 2x and then minus 9 equals to 0. And then we can try to find the factors here, isn't it? We can do like this. So 3, 2x, and then 3, 2x. And then, okay, we look for the factors here, okay? 9, to get a 9 here, what must happen? We must have a 9, a negative 9, and a positive 1. Yes, we want to have a negative 8 in the middle, okay? So this means that, therefore, 3 to the power 2x equals to negative 1, or 3 to the power 2x equals to 9. So is 3 to the power 2x equals to 3 to the power 2, okay? So it means therefore x will be equal to 1. Because 2 will be equal to 2. So then here, this is not valid. Not valid. Or you can say no real solution, because there is no exponent that can be, the exponent this side is not negative, okay? So it can be positive on the left and then it becomes negative on the right. No real solution. So yes, that is it for 1.1.4. What we had to see here is that what there is a 4 and there is a 2. So 4 here is 2 times the value of 2. So we can take the 4 and we raise the 4 to a value of 2, to a power of 2 here. So now number 1.1.5. So it's going to be negative x squared minus x plus 12. Negative x squared minus x plus 12 is less than 0. So the thing that before we try to factorize here, we should try and make the coefficient of square, the highest order here. We must try and make it positive. So we change everything, okay? So we say x squared plus x, and then here we're going to have a minus 12 is greater than 0. And then we can factorize, okay? We can say it's greater than 0. So then it's going to be x and x. So the factors of 12 is 4 and 3, okay? It's 4 and 3. So if we want to have a positive, it means the bigger number must be positive, okay? So it means the 4 here must be positive. Then what we do in this case, if we have an inequality, it means we must test the numbers, okay? So the solutions that we're going to have here is negative 4 and positive 3, okay? Negative 4 and positive 3. So we test the intervals here, okay? We test the intervals. So what do you mean we test? We take any number in any interval and we use it to test it. Let's take any number here between negative 4 and 3. Let's take 0, for example, okay? If we substitute 0 here, and we also substitute 0 here, what are we going to have? We're going to have 4 multiplied by negative 3. So I want to have negative 12 greater than 0. Is this true or false? It's false, okay? It's a false statement. So it means that this interval here is wrong. And then we can take any number here, okay? We can take any number this side. Let's say we take a 4. Here's going to be 4 plus 4. So 4 plus 4, which is 8. And then 4 minus 1, which is 1. So it's going to be 8 multiplied by 1, which is 8. It's going to be 8 greater than 0, which is what? Which is true. Then we can take a negative number, let's say we can take anything, -5. So then here you're going to have, if we substitute -5, okay, it's going to be -1 multiplied by -4, or no, multiplied by -8, which is going to be 8, again, greater than 0. So again, this interval here is also correct. You see, if you take any number from this side, we just took a -5 because it's the nearest, okay? So now let's come here. So this means, therefore, so x is this side, okay? It's less than -4. So it means that, therefore, x is less than -4, or x is greater than yes. So it's this side. So it means that x is this side. It's greater than 3, or it's this side, which is less than -4. See? So that's it. It means that these are the two intervals that gives us the solution for this inequality. And then 1.2, they want us to solve for x and y simultaneously, okay? Meaning at the same time. So here we have x minus y equals to 3, okay? X minus y equals to 3. So for 1.2, let's do it here. X minus y equals to 3. And then we can say this is equation 1. And the other equation is what? X squared minus xy minus then x squared minus xy minus minus 2y squared equals to 10. And then we can make equation 3 from this, from equation 1. Eh? We can take y the other side, such that we can say therefore x equals to y plus 3. And then this becomes equation 3. And then after that, we can substitute 3 into 2. And then we can begin solving from there. So if we substitute 3 into 2, so it means that wherever we see x, okay, wherever we see x, we must put y plus 3. So we come here. We say, therefore, y plus 3 whole squared minus y plus 3, then y, and then minus 2y squared And then so we must then solve for y. Okay. So we break it down. Okay, so it's gonna be y squared plus 6y plus 9 minus y squared minus 3y minus 2y squared equals to 10. So it means therefore negative 3y squared and then 6y minus 3y is gonna be positive 3y and then 9 minus 10 is gonna be minus 1 equals to 0. So then it's gonna be 3y squared minus 3y plus 1. 0. So we must try and factorize here and find the factor. So 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 okay, what would be the factors here? We want to get a 1, whether there should be a 1 and a 1. Okay. Okay. We want to get, so what is going to be the factor here? Did I do something wrong here? Oh, yeah. Infinity here is the y squared minus 1. So it should be a 2y. So it should be 1. Yeah. What is the factor? A. Yeah, so I'm sorry about that. I made a mistake there. Okay? Sorry about that. I forgot the other y here. Okay? So now when we find factors here, it's gonna be if we wanna have a negative 3 here, it's gonna be 2y, and then yes, it's gonna be 1 1. Yes. And it, so it's gonna be therefore y equals to 1 over 2 of y equals to 1. So then it's then gonna be therefore x equals to, because add we have to add a half here. 1 over 2 plus, so it's going to be 7 over 2, or x equals to 4, because it's going to be 1 plus 3, right? It'll be 1 plus 3 over there at the top. Okay, so yeah, that's 8 for 1.2. Okay, yeah, I'm sorry about the mistake here. It was not a 3 here, it was a 2. So I'm sorry about that. Now let's move on to 1.3. So they say given a plus b, a minus b equals to 2b, 8a minus b. Then they say a is greater than 0 and b is greater than 0. Determine a plus b squared in terms of ab. Okay. Um, so they said a plus b squared. Okay. So what we can see that is that on the right, what do we have on the right? We have a difference of 2 squares, isn't it? We have a difference of 2 squares. So this means that let us write down the thing first. Okay. 1.3. 1.3 is that a plus b and then a minus b. Okay. And then a minus b equals to 2b and then 8a minus b. Okay. 2b and then 8a minus b. 2b and 8a minus b. 8a minus b. So then it's going to be therefore, this is a difference of 2 squares on the left. Okay. So this is equal to a squared minus b squared. When you factorize here, this is what you must get. And then on the right side, it's going to be 16. And then b multiplied by a, it's going to be ab. And then 2b multiplied by b is going to be minus 2b squared. So then it's going to be, therefore, a squared minus b squared. And then plus 2b squared is going to be equal to 16ab. So this means, therefore, because negative b squared plus b squared is going to be a squared plus b squared, which equals to 16ab. Sixteen AB. 16. So that is so okay. Now the question is saying find what? Determine a plus b squared. Okay. Now, okay, a plus b squared. Now when we find a plus b squared, what's gonna happen? It's gonna be become a plus b squared will then be equal to, isn't it, we have two brackets, a plus b, and then we have a plus b. So it's going to be a squared plus ab, and then plus ab, and then plus b squared. So we can group a squared and b squared together in it. So we have a squared plus b squared. And then ab plus ab becomes what? 2ab. And then a squared plus b squared is what? Is 16ab plus 2ab. So this is equal to 18ab. See? So this is the kind of question that requires you to think out of the box a bit. Okay. You need to think out of the box a little bit. It's a challenging question. Okay. I think for question 1, that wraps it up. Okay. So guys, you see, if you have question and you don't understand something, you leave your questions in the comment section, please. Okay. So I will attend to your comments and guys, look, I'm sorry if I can't get to some of your comments. So please don't get angry in the comment sections. Okay. If I don't answer you, what you can do is you can look at other comments. If you don't get answers to your specific questions, you can go and look at the other comments, because you may find that sometimes you are too many and I can't get to all of you see. Or sometimes I ignore your questions because you are asking the questions that was asked already. Okay. So don't get angry in the comment section if I can't get to you. Okay. So let us get to question 2. Okay. I think that we're done with question 1. So given the arithmetic pattern, okay, so 181, then blah, 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 blah here, then 9, 4, 5, 5, and then 1. We can see that the difference here is what? There's a constant difference here of what? -4. So they say determine the nth term of the arithmetic sequence. Okay, the nth term. So the nth term is Tn. Tn. So if this is an arithmetic sequence, what's going to happen? So 2.1.1. For an arithmetic sequence, this is what we know. Tn equals to a, then plus n minus 1, and then d. So it's going to be equal to a, which is the first term here that we have, is 181. Okay, 181. So it's going to be equal to 181 plus, and then n minus 1, then -4. So then Tn is going to be 181, and then minus 4n, and then plus 4. So it's going to be 185 minus 4n. That is our nth term, or Tn, okay? And then 2.1.2. What do they want here? So 2.1.2. Calculate the number of terms in the sequence. So calculate the number of terms in the sequence, okay? So we want the number of terms. So we must look at the last term, okay? The last term here, which is 1, okay? So we're looking for n because we're looking for the number of terms. So then we say that Tn equals to 185 minus 4n. So this means that therefore 1 equals to 185 minus 4n. So it means therefore 4n 185 minus 1. So it means therefore n equals to 184 over 4. We divide by 4 here in order to get the n. Okay. So you use a calculator. So it gives me 46. Yes. So there are 46 terms, okay, in this arithmetic sequence. That's what we get for our n, okay. Then 2.1.3, what are they asking for? They say calculate the sum of the series 181 plus, and then plus other numbers, plus 17 plus 13. Okay, so we can see that the difference here is still a 4, isn't it? So it's up to 13 because we know that after 13, so what you can see here is that it goes from 17 and then it goes to 13, okay? It means that after 13, then there'll be a 9, because now if you minus 4 here, you get a 9, and then after the 9, there will be a 5, after the 5, there will be a 1. So these terms here are not there, okay? So there are 3 terms that were eliminated from this sequence, you see, from this pattern. So isn't it we can go from 1 to 5, and then from 5 to 9, and then from 9, then we go to 13. But then that's where they stopped. So it means that the last 3 terms were removed from the what? From the pattern. So if the last 3 terms were removed, so it means that our n here, 2.1.3, our n is going to be 2.1.3. Our n is going to be 46, né? And then we minus 3, because those are then there were 3 terms that were eliminated, you see. So then our n in this case is 43, but then the sequence is still the same. See, the pattern is still the same, and it's an arithmetic pattern. So if we want the sum, what do we do? If we want the sum, we must come and we use the formula for the sum. Okay, we use the formula for the sum here, but then with 43 terms. So the formula for the sum, if you are doing an arithmetic pattern, Sn is going to be equal to n over 2 into 2a, and then plus n minus 1, and then d. So we can use this formula, isn't it? Or we can use the other one to find the sum also. Then the one that uses the last term is going to be equal to n over 2, and then a plus l. Okay, l being the last term of the game of the pattern. So again, we said our n is 43, not 46. So it's going to be 43 over 2, and then 2. Our first term is 181 plus, and then again 43 minus 1. Okay, then our d is -4. And then you use a calculator here to get the sum of the sequence, or the sum of the series. And this side is going to be 43 over 2, and then 181, and then plus, and then our last here is going to be, we go here, it's going to be 13, okay? Because it doesn't reach at 1, okay? So it's going to be, our last term in this case is 13. The last term is 13, not 1. So it's going to be 181 plus 13 here. So yes, then you use a calculator in each case. So it's going to be 43 over 2. 4171, then 417. You use a calculator there. And then we go to 2.1.4. What do they want? Write the series in 2.1.3 in sigma notation. Okay, they want this thing in sigma notation. So they want the one in 2.1.3, the one with 43 terms, remember, okay? Is the one with 43 terms. So sigma notation is how? Sigma notation is, isn't it? We must do the sigma like this. And we must have the first term and the last term. And then here we must have the what? The Tn here. So n equals to 1. And then until 43. And then here we must have Tn. Right? Tn must come here. See? So the general term must come inside the bracket here. So what is the general term in our case? We found Tn is 185 minus 4n. Okay, so this is the sigma notation that they are asking for. And then 2.2, the general term of a quadratic sequence is Tn equals to an squared minus 5n plus c. It is given that T4 equals to 18 and T3 equals to T2 plus 5. Okay. Calculate the values of A and C. Okay. So right here we can get T2 and we can also get T4. Okay. We can get T2 and we can also get so T4. So we can make up three equations, isn't it, out of this? Because we can have, okay, let's do it here on the side. T4 is 18, okay? So T4 says an squared minus 5n plus c. Um, okay, T4, we can start with T4, okay, for 2.2. So then T4 would be equal to, so we substitute 4. So it's going to be a4 squared minus 5 into 4. Okay. A4 squared and then minus 5 into 4. So it's going to be a and then 4 squared minus 5 and then bracket 4, then plus c. Okay. Yes, c. So then it's going to be therefore 18 equals to 16a squared, or 16a minus 20 plus c. So it means therefore 38 equals to 16a and then plus c. Okay, this is what we got from T4. Okay, so we can write c in terms of, we can say then c equals to 38 minus 16a. You see, and then we can come and do T3. Okay, T3. T3 is going to be, if we get T3, T3 is going to be a and then 3 squared. Oh yes, if we are saying that the T3 equals to T2 plus 5, what does that mean? Okay, we substitute 3 and we substitute 2. Okay, so we come here, we substitute 3. So we're going to say a and then 3 squared minus 5 times 3 and then plus c equals to, oh no, plus 5 here. So then it's going to be 2 squared minus 5 multiplied by 2 then plus C minus 5 minus, so it's going to be minus 15, and then plus C, and then it's going to be equal to 4A minus 10 plus C plus 5. So the C will disappear, and the C will disappear because it's on both sides. It's going to be therefore 9A minus 15 equals to 4A minus 5. So it's going to be therefore 5A equals to 10. So therefore A equals to 2 if we divide by 5 on both sides. So then after we get A, then we can take A, we substitute A here. We substitute A this side in order to get C, isn't it? So then we then can say therefore C equals to 38 minus 16 and then times 2. So it's gonna be 38 minus 32, which is gonna be 6. And that's what we get for. So that's the value of C that we get. So does that answer the question? So our question is saying, calculate the values of A and C. Okay. Yes, that's it. Okay, now that's it for question 2. Question 2 was 14 marks. Okay. Now let's move on to question. So I hope that it was clear here. Hope we understood everything. Okay. So let's move on to question 3. So question 3 reads as follows. Okay. They say a computer tablet is infected with a malware program, computer-generated virus. It has resulted in its flat rectangular screen being affected by quarter 1/4 of the screen being blocked on the first day. On each successive day, it blocks a further portion of the screen as big as 1/4 of the area it blocked on the previous day. The malware program continues to act indefinitely. Before the infection, the area of the screen was 800 square units. Okay. Determine the total area blocked at the end of 4 days. Okay. They say do not round off your answer. Okay. The total area of the block after 4 days. Isn't it? This thing was okay. Let's do it over here. 3.1.1. So the first day is going to be 800. If they say after 4 days, and then it's going to be, or we can say, multiply by 1 over 4. And then on the second day, it's going to be 800 multiplied by 1 over 4 multiplied by 1 over 4. So on the first day is 1, and then plus on the third day, they are going to be 3 now. It's going to be 800 multiplied by 1 over multiplied by 1 over multiplied by 1 over 4. Then on the third day, they are going to be 4. It's going to be 800 and then multiplied by 1 over 4 multiplied by 1 over 4 multiplied by 1 and then multiplied by 1 over 4. Like that. Okay. So then it's going to be equals to. Okay. So they say do not round off your answer. If you say do not round off your answer, yes, 3.1.1. Okay. Do not round off your answer. So whatever answer that we get is what we must write down. So the answer must not be rounded off here. So then it's going to be 200 plus, then again use a calculator here. It's going to give you 50. You just keep multiplying by 1 over 4. Then you say 50 multiplied by 1 over 4. You get 12.5. You say 12.5 multiplied by 1 over 4. And you get 3.125. So it's equal to 265. Point 625. So square units. Square units. So this is the area in the first 4 days that would be blocked out by the virus. If the malware program continues to act indefinitely, what fraction of the user screen will eventually be blocked out? So if they say indefinitely, okay, the key word here is what? Indefinitely. Indefinitely here, what does that mean? It means that it's the sum to what? To infinity. You see? So they're not saying that it's going to stop at some point. They're saying that it goes indefinitely. Okay? So we must use, because our R here, our ratio is what? Is 1 over 4, because it keeps on multiplying by 1 over 4 in each consecutive day. as each day passes. Okay. So then we must look for the sum to infinity of 3.1.2. So the sum to infinity here equals to 200. And then, so this is the first term is 200. So you use a calculator here. So we use a calculator here to get the answer. It gives me 800 over 3, which is equal to 266.67 square units. And then let's go to 3.1.3. Oh no, there is no 3.1.3. So it's 3.2 next. So 3.1 is finished. So we go to 3.2. The sum of the first n terms of a geometric series 9, 6, 4, 9 plus 6 plus 4 is greater than 25. Calculate the smallest value of n that will give a sum greater than 25. Okay. So, okay, this is a geometric series. Okay, so it means that there is R. Okay, geometric series means that there is a constant ratio here. So we must divide in it T2 divided by T1 to get R. And then our first term is 9. Okay, so 3.2. So R will be T2 over T1. To get the ratio here, we take T2 and we divide it by T1. It's going to be 6 over 9, which is going to be 2 over 3. Okay. So they say the sum. So if we know that sum equals to it's going to be A and then 1 minus R to the exponent n divided by 1 minus R. Okay. and they said it's greater than 25. Okay. So our R is 2 over 3. Nine and then 1 minus 2 over 3. And then to the exponent n, then 1 minus 2 over 3. And then it's greater than 25. So then we must simplify, isn't it? We're then going to say, therefore, this over here is going to give us what? 1 over 3, isn't it? We say 1 minus 2 over 3. And then if we multiply this, it's going to give us 27. Okay. 1 minus 2 over 3. And then n. Okay. So then it's going to be therefore 1 minus 2 over 3 to the power n is greater than negative 2. Okay. So then it's going to be therefore, if we take this, that side, it's going to be 3 is greater than, or it's greater than 2 over 3, and then n. Okay. And then after that, okay, what happened here is we have 27 n and then greater than 25. Okay. Okay, wait. Did I make a mistake here? Here, isn't it? It's going to be greater than 25. Okay. And then here, it's going to be, oh yeah, made a mistake here. So it's going to be like this. Should be like this. Then we must divide by 27. So it's going to be 1 minus 2 over 3 to the power n is greater than 25 over 27. Yes, it should be like this, and then we can bring it this side. So then it's going to be 1 minus 25 over 27 equal greater than, well, there's an n here. Okay, stick. So this is an n here, it's not a 2. So then it's going to be 2 over 3 to the power n. And then if we say 1 minus that, it's going to be, therefore, negative 2. It's going to be negative 2. And it's going to be 2 over 27 equals to, and then 2 over 3, and then to the power n. keep writing equal to here. It should be greater than. It's gonna be greater. So then in order to get n, we can use logarithms, isn't it? Because then it's gonna be therefore it's gonna be log of this divided by log of that. It's gonna be n equals to log of log 2 over 27 divided by log 2 over 3. So here, this is where you use a calculator. We divide by the log. Keep writing equals to, okay. So it's gonna be n, because now this comes this side, it's gonna be n equals to. Oh, then we're gonna change the direction, isn't it? Because these logs are what? They are negative values. So the log here is gonna change. So these are the laws of logarithms. So if we divide by this number, we have divided by a negative value. So this will change direction and face the other way. Okay. So then you use a calculator there, which this thing is equal to. You use a calculator. Log. So it gives me 6.419. Gives me 6.419. Okay, so what does this mean? Okay, because they said, so it means that it's greater than 6. So what does that mean? The sum of, calculate the smallest value of n that will give a sum greater than, okay? So that value of n cannot be 6, okay? So it means that n here will be equal to 7, okay? Smallest value that will give, because the n that we get here is greater than 6. Remember that n has to be a whole number. So the smallest value that will give the sum greater than 25, the n has to be 7, because we have to take a whole number, you see. Take a whole number, that's why. So so yes, that's okay. That's the finish. That's the end of question 3. Okay. Question 3 was 11 marks. Okay, that is the end of question 3. If you don't understand something again, you're free to leave your questions in the comment section. Now let us go to question 4. Oh, so now question 4 is graphs. Okay, we're given the hyperbolic function. We can see the hyperbolic function here already, and this is the parabola or the quadratic function. So the question says, in the sketch below, the sketch below shows the graphs of f of x, negative x squared minus 4x plus 3, and g of x equals to A over x minus p plus q. And then they say x is greater than p. A and B are x-intercepts of f. Okay. C is the turning point of f. D, 0 and 10 is the y-intercept of G. Determine the length of AB to the nearest two decimal places. So how can we find the length of AB? That isn't it? We have to find the intercepts. The intercepts of what? Of the graph of f. Okay. We have to find the intercepts of the graph of f. So for the intercepts, we know that y equals to 0. So we have to equate, we have to say 0 equals to. So for 4.1, 0 equals to negative x squared minus 4x. Negative x squared minus 4x. So therefore 0 equals to x squared plus 4x minus 3. So we can find those intercepts, okay? So we can then say, therefore, x equals to negative b plus or minus b squared minus 4ac all over 2a. And then minus 4 plus or minus 4 squared minus 4, and then minus 3 all over 2a. So it's going to be negative 4 plus or minus. And then here it's going to be 16 plus 12. So it's going to be 28. And then all over 2. And then you use a calculator. So therefore, x equals to negative 4 plus square root 28 over 2, or x equals to negative 4 minus square root 28 all over 2. So equals to. So, okay, use a calculator here. We get, I get 0.645. Then here I get negative uh, negative 4.645. So therefore, AB equals to 0.645 minus negative 4.645. So then it's equal to, again, so it's going to be a plus here. You use a calculator. Gives me 5.29 units. Okay. Gives me 5.29 units. Okay. So we go to 4.2. What are we required to find here? So 4.2, let's say determine the coordinates of C. Okay. Okay, well, okay, the coordinates of C. C is the what? C is the turning point, isn't it? So isn't it we can get, if it's a parabola like this, we know how to get the x coordinate, isn't it? X will be equal to negative b all over what? 2a. Okay. So it's gonna be minus b is how much? B is 4. 4 over, so negative 4 over 2 into a. So a is how much? A is 1. So it's gonna be 2 into 1, and then so it's gonna be 4 over 2, which is negative 2. Okay. And then once we have negative 2, then we can substitute in it to find f of negative 2 be equal to negative 2 squared plus 4 into negative 2, negative 2 squared plus 4 into negative 2, and then minus 3, and then minus 3 equals to, so it's going to be 4 minus 8. So 4, okay, maybe let's use the what? The original equation, isn't it? Here it's going to be negative and plus. Okay, so it's going to be negative, and then here it's going to be a plus. Here we're going to we use the original equation. Negative. So it gives us negative 4 plus 8. So it's gonna be 7. So the coordinate, yeah, that's what the question say. Determine the coordinates of C. Okay. So C is the what? It's negative 2 and 7. C is negative 2 and 7. Those are the coordinates of C. And then for 4.3, 4.3, what do they want? Find the equation of G if the asymptotes of G intersect at the turning point of F, okay? So the asymptotes of G intersects at the turning point of F. Okay, so they intersect here. Okay, so that will give us, because the values there is what? -2 and 7. What will that, how will that help? It will give us P and Q, isn't it? It will give us P and Q. It means that in that case, it means that P will be equal to, and Q will be, well, Q will be equal to 7 because it will be the Y value, isn't it? Q will be equal to 7, and then P will be the opposite of this. So if we have a -2 here, then we're going to put a +2. Okay, so then we can substitute. We can go to the original equation. We can use D here. We know that when x is 0, y is 10. Okay, that's one of the coordinates here. The coordinate of D here will help us out when x is 0, y is 10. So then our equation here is going to be y equals to a over x plus 2 and then plus 7. We're going to have y equals to a x plus 2 and then plus 7. And then we know that when x is 0, y is 10. So it's going to be a and then 2 plus 7. So it means therefore a will be equal to 6, isn't it? Because when you put 6 here, you get a 3, 10. So then the equation, then it means therefore g of x. So therefore g of x equals to 6 over x plus 2, then plus 7. And then just a useful constraint here is going to be because they told us that x is greater than p. So let's say x greater than -2. Because isn't it? That's what they told us. So this is the equation. And then 4.4. What do they want for 4.4? We are asked they say determine the values of x for which f prime of x is greater than 0. Okay, so for which f prime of x is greater than 0. Isn't it at the turning point here? So that means that where the gradient is positive. So here you have -2 and 7. And then, so before that turning point, before the turning point here, the gradient is positive. Right? So it means that all the values where x is less than -2, you see. Determine the values of x for which f prime of x is greater than 0. It means where the gradient is positive, those values are x less than -2. Okay? So they describe the transformation from f to h. If h of x equals to x squared plus 4x minus 15, x squared plus 4x minus 15. So x squared plus 4x minus 15. So we can see that these values are now positive. And then we have a what? We have a 15 here. Okay. So what will happen is we are going to reflect something. There is going to be some sort of a reflection because the values are changing from negative to positive. Okay. So for 4.5, okay, how are we going to describe the what? The transformation here. So we reflect f in the x-axis, and then translation of 12 units down. Determine the values of x for which g of x divided by f of x is greater than or equal to 0. So g of x over f of x, okay? So g of x over f of x. Okay, so is greater than or equal to 0. So meaning that where both of them are what? Are positive, okay? So, okay, where both of them are positive is going to be here. So it's between this -2 here. And then it's also going to be at the x-intercept here. And at the x-intercept, the value of the x here, we have it. Here is -2. And then here is the intercept that we found. So we have to go back to the intercept. It's the positive intercept, so it's 0.645 here. 0.645. Okay. So this is greater than or equal to. It means that that value is also included. Okay? Yeah, but then it's f. If it's g over f, yeah, so if it's g over f, then it will not be included. So it means that because at that point f becomes 0, so it's going to be from -2, and then what is that number? 0.645. 0.645. So this is the answer for 4.6. Yes. So it ends here. So question 4 was 17 marks and it was based on functions. Okay. Let us move to question 5. So now, question 5 to say what? Consider the following function. F of x equals to log x base 4 over 3. The base is 4 over 3. So it's a logarithmic function. Write down the coordinates of x-intercepts of f. So you can see this is 1 mark. You see, you should be able to read this thing from the graph. See, you should be able to read this thing from the graph. Okay? The x-intercept, what does that mean? Y equals to what? 0. Okay. Y will be 0 when x is 1. You see, if you put 1 here, log 1 will give you 0. So you should know your logarithms here. So it's just gonna be 1 and 0. See, you should read this thing from the thing. It's just 1 mark here. You don't need to do a long process. They expect you to be able to read from the what? From the function. You don't expect to do a lot of steps to get 1 mark. Then 5.1.2. Determine the equation of the inverse of f in the form f prime of f inverse x equals to. Okay. Again, you see, this is 2 marks. So it's going to be f inverse x equals to, we take what we have here. We take this. See, it's going to be 4 over 3. And then to the exponent of what? Of x. F prime of f inverse of x equals to this. Again, you are expected to be able to read. Okay. Sketch the graphs of f and f inverse on the same set of axes. Clearly indicate which one is f and f inverse, as well as the intercepts with the axis and asymptotes. Also, sketch the axis of symmetry of f and f inverse and write its equation. Yeah. So both of these graphs are going to cut at 1, isn't it? When x is 1, y is 0. Okay. 5.1.3. So when x is 1, y is 0. So means the graph will come out like that. Something like that is because it's a curve. And then the other one, so this is the x-axis and this is the y-axis. And then the other one will be the opposite, isn't it? Because now here you have a 1 and then here you also have a 1. So this one will now be like that also. Because they are a reflection of each other. and about the axis of symmetry. So then it will go so this will be F and this will be F inverse. And then the axis of symmetry here will be y equals to x. So yes, this is what we are. Okay, what else are they asking? So they say sketch F and F inverse on the same. Clearly indicate which one is F and F inverse, as well as the intercepts with the axis and asymptotes. Okay. Okay, the asymptotes. The asymptotes will be the lines, isn't it? The axis is the asymptote and the y-axis is the asymptote. So the asymptotes will be the y-axis and the x-axis to the graphs. So I think we've shown everything. Okay. Also sketch the axis of symmetry and of F and F inverse and write the equation. Yes, the axis of symmetry is this. It's the line of reflection, and the name of this line is y equals to x. So let's move on to 5.1.4. If A, okay, E, and -2 is a point on F, calculate the value of E. Okay, so it means that our y is what? Our y is -2. Okay, so then we know that f of x here that we're given, so y equals to log, okay, 4/3. So y equals to log x and then 4/3. So then we have to then say -2 equals to log x and then 4/3. So then it means therefore we can find x, isn't it? It means if we take this, that side is going to be therefore x equals to 4/3 -2, which equals to 3/4 if we use the loss of exponent and then to the power 2, which is going to be 9/16. Okay, so this means therefore E equals to 9/16. Okay, it's fine if we leave it here because they don't want any decimals. They didn't ask us to round off, isn't it? And then 5.1.5, okay, write down the domain of F. Okay, F is this, so the values of F go from here. They don't touch the y-axis, so they go from 0 until infinity. So it's gonna be from here until infinity. So 5.1.5. It's going to be x is greater than 0, x, the element of all real numbers, the element of real numbers. Then after 5.1.5, okay, then we go to 5.2. Then we go to 5.2, 5.2.1. What are you saying here? Given p of x equals to 2 over 3 to the exponent x and then minus 1. Give the equation of t if t of x is the reflection of p in the y-axis. Reflection of p in the y-axis just means that the x here will become negative, isn't it? X will become negative. T of x, if we reflect in the y, t of x will be equal to, and then it's going to be a negative x, and then minus 1. Two over 3. Okay. Write down the range of p. The range of p. Okay, so the asymptote here, this is going to be the what? The asymptote, okay? So if it's positive, it means that it will go like this, isn't it? And the asymptote here will be a negative 1. So it will never touch a negative 1, but it will go up. And it will cut at 0. Okay, cut at 0. So the range is from negative 1 and all the way until infinity. Okay, so all the values that are greater than negative 1. So y will be greater than negative 1. And then all the real numbers. Y is the element of real numbers. This is the range of f. And then after that, okay, so that's the end of question 5. We're gonna move on to question 6. So question 6 is financial mathematics. Okay, what are they saying? A machinery costing 27,000 rands depreciated at a rate of 13.71% per annum. Calculate the scrap value of the machinery after 7 years on the reducing balance method. Reducing balance method. What is that? On a reducing balance method. So it's gonna be P1 minus I. So it's gonna be 27,000 then they said after 7 years. So the percentage here is going to be 13.71 over 100. And then to the power of 7 equals to. And then you use a calculator here. We use a calculator. Subtract. It gives me okay, let me write it down this side. It gives me 9,618.05. And then 6.2. So 6.2, what do they want? So they say a loan of 800,000 is taken out at an interest rate of 13% per annum, compounded biannually. It is repaid by equal biannual payments of 57,000 rands and a final payment less than 57,000 rand. How many payments are required to settle the loan? Okay, how many payments? So this, if they say how many payments, what do they want? They want n in it. And what we have here is the what? Is the present value. So again, 13% biannually. Okay, biannually. What does this mean? It means that 2 times in a year. Okay, 2 times in a year. So the interest would be divided by 2. Okay. So what we have here is the what? Is the present value, it's not the future value. Okay, because the loan is taken out. This is not the amount that we're going to get in the future. This is the amount that we have right now. Okay, the loan is taken out. So this is not a future value, it's a present value. See? So we're going to use the equation for the present value here. Okay. The present value equation, what does it say? It says P equals to, and then we say X over I. So then our present value here is 800, isn't it? So yes, our is 800,000. So then our X is 57,000. So then we have 800,000. 800,000 equals to 57,000. 57,000 and 13, 0.13, then 2, and then negative n. 0.13, then divide by 2. And then we must find n, isn't it? We must find n here. So what is the first thing we do? We divide. So we can start by cancelling the zeros. We cancel the 3 zeros, okay? So then we have 800 over 57, okay? And then multiplied by 0.13 over 2, okay? Equals to, okay, if we bring the 1 here, it's going to be minus 1. This one, if it goes that side, it's going to be minus 1 equals to 1 plus 0.13 over 2, and then negative n. Okay, then we have to simplify it further. So it means therefore, so if we type this into a calculator, this can be typed into a calculator, right? Then you get the answer. You type this into a calculator, and then it's equal to log, so 1 plus 0.13 over 2, and then negative n. So this is typed into a calculator, and then we get how much? Okay, as a fraction, it gives me 5 over 57, means therefore okay, we can make this thing positive here. We can make it positive. We can say 1 plus 0.13 over 2. Then it means therefore n will be equal to log of 57 over 5 divided by log of 1 plus 0.13 so yes, then you use a calculator. So we use logarithms here to bring the n down. Okay, so you should understand what your logarithms, how your logarithms work here. So again, you're going to use a calculator. You type all that thing into your scientific calculator. So this will give us the n, isn't it? It gives me 38.6442. Okay. So the n has to be, if they say how many payments, it means that the n has to be what? Because they say how many payments, which means they're looking for n. So it's gonna be we're then going to say therefore n will be, because 38 will not be enough because there are still decimals here. So it will have to be a minimum of 39 payments in order to cover this loan. It has to be at least 39, because if you say 38, those decimals are here will not be accounted for. So it has to be a minimum of 39 payments here. Okay. Hope that makes sense. This was 6.2. Okay, let's move on to 6. Okay, this was 6.2.1. 6.2.1. So we have to go to 6.2.2. What is the outstanding balance on the loan after the final payment of 57,000? Okay. After the final payment of what? 57,000. Okay. So the outstanding balance, okay, we have to take, okay, what is left here, these decimals, because there is going to be 38 payments. And then the other payment is not going to be a full payment. It's going to be a payment of less than 57,000. So we have to take those decimals here, because the 38 payments is the ones that are going to be full. The payment number 39 will be those decimals that are left. You see, there are decimals here that are left. That will be the final payment. So the n will be that number. So the outstanding balance, meaning the present value at that point. Okay, we have to find the present value, isn't it? 1 minus and then 1 plus, and then 0.13 all over 2. And then we're going to take those negative n. We're going to take those decimals that are left. You understand? So, okay. Negative 0.6442. And then we get the outstanding, we get the present value of the loan. So this is what is left after we made 38 payments, meaning that the 39th will be the decimals that are left over. It won't be 57. It will be something else. So it will be, okay, you use a calculator here. You use a calculator. It gives me 37, 131.85. So to 2 decimal places. So it will be 37,131 rands, 85 cents. Oh no, I used the wrong number here. This was the wrong number. I substituted wrong numbers there. So the true value here should be 84,865.59. Okay. And then this is what the present value would be. So this would be the last payment. Okay. This would be, it won't be 57,000, you understand? This will be the last payment that we make. So it will be the 39th payment, that one. So now 6.2, but they say, what is the value of the final payment? What is the value of the final payment? So now the final payment, okay. So then we're then going to say 6.2.3. 6.2.3. Okay. The final payment here. The final payment, because this thing is what? Is compounded. Okay. Be equal to, this is what we're going to pay. 865.59. 0.59 and then into 1 plus 0.13 over 2, and then n will be 1. Because it will be one payment only, that is like this. All the other payments will be 57,000. You understand? And then so it's going to be 37.85. This will be the value of the final payment. Then we move on to 6.3. So now for 6.3, they say a company sold shares at a fixed price of 765 rand 50 cents per share over 4 years. A minimum guaranteed interest rate and over the 4-year period is 7.4% per annum compounded quarterly. Charlene purchased 10 shares every quarter over the 4-year period. So her first purchase was at the beginning of the first quarter. Okay. So at the beginning of the first quarter, okay, of the 4-year period, and then at the end of each quarter. Okay. This is important information here. So you underline what they're saying. Okay. So now they're saying if she purchased what? 10 shares every quarter. Okay, 10 shares every quarter. So per share. So then we must be able so it means that we must take this price here per share and we multiply it by 10. Okay. So it's 765.50. Okay. 6.3.1. So 6.3. So 765, 50, then multiply by 10 because she bought 10 shares. So it's going to be 765, 5. This is each quarter. Okay. And then they say what? Calculate the minimum value of investment at the end of the 4-year period. So if it was at the beginning, okay, and then at the end of each quarter. So the end here is going to be 4 and then multiply by 4. So we were looking for the what? The future value here. See, we're looking for the future value that she's gonna have. So then future value here is gonna be x, and then 1, yeah, 1 minus I, okay, no, 1 plus I, sorry, and then to the power n, and then minus 1, and then all over I. So then if it's going to be 4 years, so this is what she has each. So it's going to be 6, 5, 6, 7, 6, and then 5, 5. And then our interest is how much? Our interest is going to be where is our interest? So they gave us an interest of how much? Of 7.4%. Okay, 7.4, yeah. Then we're going to divide it by 100. So we divide it by 100, and it's going to be 0.074, and then we divide it by 4. And then if it's 4 years, it's going to be 4 multiplied by 4, and then plus 1, and then minus 1. So again, why do we say plus 1 here? Again, this is where the information that I was out, because they said at the beginning, see, of a quarter, not at the end. So that's why we say plus 1 here. It's 4 quarters in a year, and then multiplied by 4 years, and then plus 1, because they said at the beginning, you see? So you use a calculator, okay? You use a calculator. It gives me 151, 297.64. Okay, and then it should be R. And then 6.3.2. calculate the percentage profit she made at the end of the 4-year period. Okay. So, isn't it we must get the interest? Okay, so how much should, okay, so the profit here is going to be the profit here would be okay, the answer that we have here 151 297.64, and then we're going to minus 17 multiplied by her payments, so 7655 equals to 0.64. Okay, and then if the percentage profit, then we're going to take the profit and then we divide, and then we have to multiply by 100 here. So then the percentage profit would be equal to, so we're going to divide by the 17 multiplied by 1655, and then we multiply by 100 in order to get the percentage. So 21,162.64. Okay. And then you use your calculator. You use a calculator. It gives me 16.26%. That is how much I get. Okay. So 613.2. Okay, that was the end of question 6. So question 7 is right here. Question 7 is not on the next page, is over here. They say given f of x equals to, they say negative 4 over x, determine f prime of x from first principles. So isn't it from first principle we have to find f of x plus h? That's 7.1. Ne? It's gonna be and then now to get f prime of x, and we have to calculate the limit as h approaches 0, f of x plus h, and then minus f of x, and then all over h. So you have the limit, and then h approaching 0, what? -4 x plus h minus -4 over x, then all over h. So it's equal to the limit as h is approaching 0 of -4 equals to, and then, okay, we add the two fractions. So it's going to be x into x plus h, then -4x plus 4x, and then plus h, 4h plus 4h, and then all over h. And then if we divide by h, so this 2 will cancel out, -4 plus 4. And then if we divide by h, then we get x plus h, okay? And then we get 4. We get 4 on top, okay? This h will cancel the other h there, right? Because it's division. So then this thing becomes equal to, we substitute h here, okay? We substitute h and we get 4 into x plus 0 equals to 4 over x squared. That's what we get. So that is the derivative that we have here. F prime of x is, determine f prime of x if f of x equals to -5 over 2x squared. So then f prime of x here is going to be, okay, yes, let me do it here. F prime of x for 7.2.1, f prime of x is going to be 10, and then x -3 plus 4 pi, okay? The x becomes 1. So it becomes 10 plus 4 pi. And then 7.2.2 d. Okay, 7.2.2 is a bit long. So let's do it here. So it's dx over x, and then fourth root, and then x cubed. And then minus 2x to the power 5. So what we must do here is that we must simplify first. Okay? So this thing will be equal to dx, and then x 3 over 4 minus 2, and then x over 5, and then over x. And then if we can simplify, we can minus 1 and minus 1. Okay. So then it's going to be equal to dx. We have an x here. We're going to say x 3 over 4 minus 1 minus 2, and then 5 minus 1. And then so it's going to be equal to dx negative 1. Then okay, if we find the derivative, then we're going to minus 1 minus, it's going to be negative 1, okay? And then here is 2 times 4, and then x to the power 3. So then this becomes negative 1 over x, negative 4, and then minus 8, and then x over. So we make a negative forward. So if we write this thing in set form, it's going to be negative 1. 3 cube root of x to the power 4, then minus 8x to the power 3. So you can leave it here in negative exponents, or you can leave it here as in set form. Okay? In set form with radicals, okay, and positive exponents. Okay? Now, and then the next one, 7.2.2, 7.2.3. Dy over dx if y equals to, okay, y equals to x squared minus x minus 6. 7.2.3. X squared minus x minus 6. So now, then we should factorize here. We should try to find the factors here. So it's going to be x and then x. And then it's going to be plus 2. So it means therefore, so then dy over dx is going to be equal to 1 because the y has been simplified, okay, into x plus 2. So it helps to simplify the expression that we have sometimes because then the dy over dx is difficult to find. It's difficult to find when you have that long thing there, but once it's simplified, it's easier to find dy over dx, okay? Okay, so that was the end of question 7. Question 7 had what? 13 marks. And it was differentiation. Okay? Let's go to question 8. Question 8, they say, the diagram below shows the graph of y equals to g prime of x, where g of x is equal, so these are cubic functions, ax cubed plus bx squared plus cx plus d. The graph of g prime of x cuts the y-axis at 0 and 1. The x-axis and the x-axis at negative 1 over 3 and 0 and 1 and 0. Okay. That when we have those points, we can find the what? The equation for the g prime of x. We can find it. Write down the coordinates of the stationary points of g. Okay. Write down the coordinates of the stationary points of g. So that's where the g prime of x will be what? 0. That's why g prime of x will be 0. Write down that. I think they meant to say the x coordinates because if you can't write down the coordinates, Okay, this was a mistake here. It should be write down the x coordinates, okay, the x coordinates of the stationary point. Because if it's 2 marks, you can only get the x coordinates, which is this x negative 1 over 3 and 1. So x equals to 1 and x equals to negative 1 over 3. These are the what? These are the x coordinates. There is no way we can know what the coordinates are at this point. And then 8.2, they say, determine the x coordinate of the point of inflection of G. Okay. Okay, so we have to add the 2 and then we divide by 2. And we have to say this plus that to get the stationary point here, because this is the graph for the G prime. So the stationary point will be the point of inflection in the original equation, the cubic function. So the stationary point here, we have to say this plus that, and then we divide by 2. So it's going to be negative 1 over 3 plus 1, and then we divide by 2. And then we get that. We get the answer here. Which is going to be 1 over 3 equals to x. And then here, 8.3, they say determine the values of x for which function of g is increasing. Okay, the function of g is increasing. That means where the what? Where the g prime is positive. You can see that g prime is positive where? From negative 1 over 3 until 1. Okay, so from negative 1 over 3 until 1. So here the answer here is, for here, it's negative 1 over 3 less than x, and then less than 1. That's what it is. And then, so they say that, and then for 8.4, determine the equation of g prime in the form g prime of x equals to px squared plus qx plus r. Okay. Okay. So, okay. 8.4. So 8.4, we're going to say what? Y equals to a, and then x plus 1 over 3, and then x minus 1. So it's gonna be, so we can substitute in it the y and the x because we have them in order to find a. So here we know that y is 1, x is 0. Okay. Yes. Y is 1 and x is 0. So we can substitute that also. So then we have 1 equals to a, and then 0 plus 1 over 3, and then 0 minus 1. Okay. So it means therefore 1 equals to negative 1 over 3 a. So it means that therefore a equals to we simplify here, a equals to negative 3. So it means therefore, y equals to negative 3 here. Y will be equal to negative 3. X plus 1 over 3 equals to, so it means therefore, g prime of x equals to, can you do that, you simplify, it's going to be negative 3x squared plus 2x plus 1. So it's negative 3x squared plus 2x plus 1. Okay? And then from there, 8.4, and then 8.5. Okay? So they say, given that g of x plus 1 passes through point 0, 0. Okay? So it passes through the origin. And then g prime of x equals to negative 3x plus 2x plus 1. Solve for g of x. Show that, okay, they say show that for g of x, a equals to negative 1, b equals to 1, c equals to 1, and d equals to negative 1. So those values that they gave us at the top, a, b, c, and d, from the equation, from the opening equation, we must show that it is equal to all those values. So now they gave us what? G, okay, passes through the point. Okay, so we can know that g of x plus 1, okay, will be equal to, so then it's going to be g of x plus 1. We write g of plus 1. This will be equal to, not g prime, g ax squared plus bx. So it's x cubed, ax cubed plus bx plus of bx squared plus cx plus d plus 1. Therefore, 0 equals to It's going to be a and then 0 to the power 3 plus b and then 0 to the power 2 plus c and then 0 plus d plus 1. D, so it means therefore d equals to -1. So it means that therefore g of x, okay, will be equal to ax cubed plus bx squared plus cx and then -1. Okay, and then so what do we know? So this means that this is ax cubed here. This means therefore that g prime of x will be equal to 3a x and then squared plus 2bx plus c. Okay, and then from here, then we can go to what we found, right? Which is equal to what we're given here. They say g prime of x is -3x squared plus 2x plus 2x So it means therefore a equals to -1. And then you come here, 2b equals to 2. So therefore b equals to 1. And then c equals to 1. Because they correspond here. Okay. So we have shown it. That's what it is. Okay. So yes, that sums it up for question 8. The others, I've done them here on the question. Okay, so that side I did 8.4 and 8.5. 8.1 until 8.3, I did them here. Okay. Because they were short. Didn't need space. Okay, let's move on to question 9. So they say what? The rectangle below extends from the origin to point A, P and 0. Extends from the origin to point A. It touches the graph of f of x at equals to -4x plus 8 at point C. And the graph of h of x equals to 4x minus 8 at point D. So, okay. So we have h of x, okay? H of x is 4x minus 8. So you can see it has a positive gradient, okay? And -4x plus 8. This is it's a positive gradient here. This is a negative gradient and a positive y-intercept, and this one has a negative y-intercept. So 9.1, show that the area of the shaded rectangle can be expressed as AP equals to negative 8p squared plus 16p. Okay, so isn't it we can start by finding CD, okay? CD, because the area for this is a rectangle, isn't it? The area will be length multiplied by breadth. So we have to find the length and the breadth, okay? And then we can multiply those two numbers, isn't it? Okay, so the A, okay, where is A? Okay, so Y is 0 here. A, okay, the rectangle below extends from the origin to the point A, P, and 0. So the rectangle, okay, this rectangle, it goes from the origin to the point P and 0. So now the coordinates here at C and the coordinates at C. The X here is what? Is P. Né? And then the Y, because the X is P for both of them. So what's going to be the Y? The Y we're going to substitute, isn't it? We're going to come here. So it's going to be 8 minus 4p. And then that one is going to be 4p minus 8. So now, if we want CD, we're going to subtract these two Y values, isn't it? We're going to subtract these two Y values like that. So, okay. If we want, so for 9.1, if for CD, if we want CD, CD will be equal to, we look at the one with the negative gradient, 8 minus 4p 8 minus 4p minus 4p minus 8. So you subtract, and then you get what? 16. And then, okay, so wait, it's gonna be 8 minus 4p minus 4p, and then plus 8. So it's gonna be 16 minus 8p. Okay. So now the area will be equal to length multiplied by breadth. Minus 8p squared. Okay. So this thing, if you multiply here, so this thing is the same as negative 8p squared plus 16p. Yes, so 9.2. Determine the maximum area of the shaded region, okay? So if we want the maximum area, then we're going to say A prime at P will be equal to 0. So it means therefore, 0 will be equal to, so it's going to be negative 16p, negative 16p plus 16. So it means that this means that p equals to 1. And then minus plus 16 and then 1. So here equals to 8 units squared. So we have to find p first, the p that will give us the maximum area. If it's, so it means the maximum area of the sheet region is 8 square units. Okay. Then 9.3. Okay, there's no 9.3. Okay. It ends at 9.2. So this was a short question. It was 8 marks. Okay. Let's move on to question 10. So now this is probability. Okay. Probability. 10.1, they say for two events A and B in the sample space S, it is given that probability of A is 0.45, probability of B equals to 0.7, and probability of A and B equals to 0.25. Draw a Venn diagram to represent the information. Draw a Venn diagram to represent the information. Okay, okay, sample size. Okay, so probability of A and B is 0.25. Okay, so the first thing that we're gonna do here is, well, we draw the two circles, and then there is an overlap. And then so the sample space here, okay, so we start with the 0.25 here, okay, 0.25, because this is A and what, and B. 0.25 is the probability of A and B, so 0.25, we start with that, okay. So there's an overlap there. So the probability of B is equal to 0.7, okay. So we must take out the 0.25 here, okay. It's going to be 0.45, you see, for B. So the one that's left for B here is going to be 0.45 this side. 0.45, because when we add with this, it must give us 0.7, you see, the total for what? For B. And then we go to A. A, the total is what? 0.45. See, this is for A. So it means that here we must have 0.2, 0.2, because when we add, we want to have, and then we must add all of them. This plus that is 0.45, plus another 0.45 is going to be 0.9. So for A and B, it gives us 0.9. Means there is another 0.1 which is left, which is outside of A and B, but it's still included in the sample space. See, so yeah, it's gonna be like this. Okay. Again, determine probability of A. Okay, this is not A. Okay, this is A prime, or the complement of A. So the probability here, okay, again, you can see, guys, this thing is 1 mark, and B, okay, equal to, and then node A and B. So then the probability of node A or B, okay, equal to node A and B. Okay. Okay, we can go to the what? Here is A. And so if you say node A and B, we have to minus this, isn't it? We have to go to 1. We have to go to 1 and minus this. Okay, minus 0.2. Okay. Oh no, not A or B. Okay, so in this case, okay, for 10.1.2, then they're saying that not A and B. Oh no, they're saying A complement, the complement of A and B. So the complement of A and B, it's gonna be this side, isn't it? It's gonna be this side. So it's gonna be 0.45. Again, guys, you see, these are 1 mark questions. These are 1 mark questions. These are questions that you must just be able to see. Okay, there's no long calculation. Okay, and then A complement or B. Okay, A complement or B. Okay, A complement or B. So yes, so it's gonna be this plus that. It's gonna give us 0.8, isn't it? Yes, it's gonna give us 0.8. 0.8. Can you see? 1 mark, guys. 1 mark. It's not a long thing. So you don't need to scratch your head too much. These are the kind of questions that you are supposed to just see, isn't it? And then they say, are events A and B independent. Motivate your answer with necessary calculations. Okay. We know what the probability of A and B is, isn't it? Probability of A and B is this. So we have to find the probability of A multiplied by probability of B, isn't it? So 10.1.4. We have to multiply the probability of A and the probability of B. So the probability of A is how much? 0.45 and 0.7. 0.45 multiplied by 0.7. Okay. You use a calculator. You multiply the two, it gives me 0.315. Okay. So this means that therefore, because the probability of A and B, we know it, isn't it? 0.25 here. We drew it here in the Venn diagram here. So this means that the probability of A and B, the probability of A and B is not equal to probability of A multiplied by the probability of B. So this means what? So therefore, the two events are therefore not independent. So now 10.2. 9 coins are arranged in a row. 4 are 1 rand coins, 3 are 2 rand coins, 2 are 5 rand coins. Okay. They say how many different arrangements are possible if all the coins of the same value are identical. Okay. How many different arrangements are possible? Okay. Now there is 4, 3, and 2. Okay. And then there is a total of 9, isn't it? So we're going to do factorials here. So it's 9 factorial divided by, and then 4 factorial multiplied by 3 factorial multiplied by 2 factorial. See? How many different arrangements are possible? If the arrangement must start and end with a 2 rand coin. Okay. So the arrangement must start and end with a 2 rand coin. Okay. So now the 9 factorial here will be reduced to a 7. Okay. and then we must multiply by 3. Okay, and then we also must multiply by 2. Okay, so, okay, now, guys, look, it must start and end with a what? With a 2 rand coin. So the factorial here is not going to be a 9 anymore. So if it must start and end with a 2 rand coin, okay, 10.2.2, what's going to happen? It's going to be 3 and then multiply by 2, multiply by 7 factorial, then divided by 4 factorial and 2 factorial. Because 2 rand, we can't say 1 factorial here because it's going to be 1. So the 3 here becomes 1 factorial because the 2 rand coins, first, isn't it? There is 3 2 rand coins. Okay, the 2 rand coins are 3. So if we take out 2, we're going to have 1 factorial here. The 1 factorial, we don't show it because it's not going to make a difference. Okay, now, and then you use a calculator here. You use a calculator. So it gives me 630. And then they say, what is the probability that an arrangement will start and end with a 2 rand coin? Okay, it's just, these are the arrangements. Okay, 630. So it's going to be 630. And then we take our answer there. So 1,260. Okay, 1,260 is what we use here. So 1,260. So the probability will be equal to. And then you use a calculator. It gives me 1/2, which is the same as 0.5. Okay, then this is the end of the question paper. So it's 150 marks. Okay. So guys, please prepare thoroughly before you go to the exam room. Make sure you have eaten and you've drank water so that you are fresh in the exam room and you don't feel dizzy or hungry or anything. Okay. So guys, yes, please leave your questions in the comment section. There's something you would like me to clarify. Okay. Thank you for tuning in into Metric Hub. I hope that was helpful. And watch out for paper 2 coming soon. I'm going to upload paper 2, okay? So this is helping us. These papers are helping us to prepare for the upcoming exam, okay? So engage with me in the comment section about something that you don't understand, okay? So thank you for tuning in. Bye-bye for now. So tune in for paper 2, please. It's coming soon. Bye-bye and take care for now. Stay focused.